There is a number in physics that we cannot measure. Not a difficult number. Not a small one. The most important number in all of nature. The number that holds the moon to the earth. The number that pulls your body toward the chair you are sitting in. The number Newton wrote into his greatest equation in 1687 and left blank because he could not measure it himself. In the summer of 1797, I tried. My name is Henry Cavendish. I was 66 years old. I stood for many nights in a dark room behind a wooden shed in London, watching two lead spheres pulled toward each other by the smallest force humans had ever attempted to count. When I was finished, I gave the world a number. 225 years later, 16 of the finest laboratories on Earth have tried to verify what I found. Not one of them agrees. 2 months ago, in a basement laboratory in Maryland, a man finished a 10-year experiment to settle the question, and made it worse. Newton's number. The one that runs through your bones, that anchors every star above your head, that decides whether a falling object lands at your feet or drifts forever past you. Physics still cannot agree on what it is, and I am the man who first measured it. Let me tell you who I was, because the man who measures gravity tells you something about gravity itself. I was born in 1731. My mother died in 1733, 3 months after my brother was born. I was not yet 2 years old. I do not remember her face. I went to Cambridge at 17. I left 3 years later without a degree. They will tell you it was common practice. What they will not write in any record is that I could not bring myself to stand for public examination. I returned to my father's house in London. I stayed there for the next 32 years. I had a second staircase built so I would not have to encounter the housekeeper. The servants received written instructions left on the corner of my desk. They replied in writing. I never married. I had no children. If a woman entered a room where I was standing, I left it. This was the entire shape of my human contact for 60 years. The man who would measure the force that binds every body in this universe to every other body could not bring himself to touch another human hand. This is who Newton's number found waiting. The idea was not mine. A country geologist named John Michell had drawn the plans years before. 2 lead spheres on a thin wire, brought near to larger spheres, would twist by the smallest possible fraction. That twist would tell you the weight of the Earth itself. He died in 1793 before he could test it. The apparatus came to me through a colleague. I rebuilt it. I changed almost nothing. He had earned it. In August of 1797, I cleared a wooden shed at Clapham Common. Inside it was a mahogany box 6 feet wide. A 6-foot wooden rod hung from a single fine wire. At each end, a small lead ball, the weight of a wine bottle. On a separate frame were 2 enormous lead spheres, 348 pounds each, the size of 2 small children, made of metal. I could not be inside the room. My breath would have warmed one side of the box more than the other. My footsteps would have corrupted the wire. So I watched through telescopes from the next room, in the dark, for nights and weeks at a time. I want you to understand what I felt during those months. Not pride, not curiosity. Something quieter. For the first time in my life, I was looking at a thing that did not require me to speak to it. The wire did not care that I could not look it in the eye. Gravity asked nothing of me except patience. And patience I had. I did not know it then. But in another country I would never see, in a basement laboratory I could not imagine, in a century I would never live to witness, another man would do exactly what I was doing now. He would give 10 years of his life to the same number. He would also fail. We would meet across 2 centuries in the same impossible measurement. After many months, I had my number. What I told the Royal Society in 1798 was that I had weighed the Earth. I did not tell them, because I did not fully understand it myself, that the number Newton had left blank in 1687 was hidden inside my measurement. Others would find it there, decades after my death. Today, physics calls that number G. In my own century, it had no name. The Earth, I found, was 5 times heavier than water. I published in the Philosophical Transactions of the Royal Society. I was 67 years old. I expected someone better than me to do it again within a year. No one did. For 97 years, my measurement from that wooden shed at Clapham Common remained the most accurate determination of gravity ever made. A torsion balance observed from the next room by a man too afraid to enter. Then, slowly, others surpassed me. In 1895, a man named Charles Vernon Boys repeated the experiment with finer wire. After him, 16 others, in laboratories across the world, used instruments that would have seemed magical to me, clocks that did not exist in my century, vacuums the Apollo missions would one day carry into space. Each one used better technology than the one before. Each one disagreed with the others. Today, physicists know the speed of light to 9 decimal places. Planck's constant, the heart of quantum mechanics, is known to 8 decimal places. The strength of the electric force is measured to 1 part in a billion. Newton's number is known to only 3 digits. 3 digits in the constant that determines the strength of the force that holds galaxies together. 16 modern experiments, 16 laboratories. Not one of them agrees with another. Now I come to the part of this story that I cannot speak of without difficulty. Because in April of this year, in a basement laboratory in Maryland, a man I have come to know better than he knows himself opened an envelope, and what he found broke something in me that I thought was already broken. His name is Stephan Schlamminger. He is a physicist at the National Institute of Standards and Technology, NIST. In 2016, he was given a single task: rebuild my experiment, use the best instruments in the world, determine once and for all what Newton's number really is. He spent 10 years. I want you to picture him. Not a young man, not a hero. A scientist who agreed in his middle years to give a decade of his life to measuring something he could not see. He worked on a single weight, swinging on a single wire, in a single basement room. For 10 years, his colleagues described him as a man walking through a dark valley. He himself called it, and these are his own words, a life-sucking experience. He could not be allowed to hope. A colleague, Patrick Abbott, sealed the true values of the experiment inside an envelope and locked the envelope away. For 10 years, Schlamminger measured a number he was not permitted to know. For 10 years, the envelope sat closed in a drawer. He walked past it every morning. In April of this year, he opened it. His result disagreed with the previous best measurement by a fraction 5 times larger than the error he had spent 10 years eliminating. He had measured the same number I had measured. He had done it with instruments that would have seemed magical to me, with full institutional support, with a decade of his life, and physics still refused to agree. 225 years, 16 laboratories, and the number had not moved 1 inch closer to being known. I have stood beside every man and woman who has ever attempted to measure Newton's number. I do not know how a dead man can stand beside the living. I only know that when Schlamminger opened that envelope, I was there. And I felt something I had not felt since 1798. I felt seen. For 2 centuries I have believed I failed because I was frightened, because I watched from the next room instead of being inside. I thought a braver man would have measured the number correctly. Schlamminger is a braver man than I was. He walked into the basement, he gave 10 years, and he failed exactly the same way I did. "It is not us," Schlamminger said, in his own words after opening the envelope, that the result was pretty embarrassing when it comes to these fundamental concepts. Embarrassing. That is the word a scientist uses when he is being kind. The gravitational constant, the number that binds every body in this universe to every other body, does not want to be found. When you walk outside tonight, look up. The moon is held in orbit by a force whose exact strength no one has measured. The stars are bound to one another by a number we cannot agree on. The chair you are sitting in, the floor beneath your feet, all of it depends on a single quantity that science has been chasing for 225 years and has not yet caught. I died in 1810, alone as I had lived. I had asked the world for nothing, not company, not children, not recognition. I had asked only to measure it. The world has not yet allowed it. In the summer of 1797, I installed a telescope through a hole in the wall of a wooden shed. I watched from the next room in the dark for many months. I thought I had found, at last, a companion who would not require my voice. I was wrong. Gravity has never been silent. It has only been waiting for someone to listen. I was Henry Cavendish. I am still listening.